All right. So far in Chapter 11, we've been doing either an arithmetic or geometric sequence or series. And then in 11-5, we did an infinite geometric series, which meant we had to add them up, going on forever, but then r had to be between -1 and 1. Today we're going to look at basically sequences that are neither arithmetic or geometric. And so they have to give me some kind of pattern to get from term to term. It won't just be adding something or just multiplying by something. It'll be a combination of the two more than likely. This is one of the notations that they can use. There's going to be 3 separate notations that are used that I'll show you today. So I see this one here says to calculate the first 6 terms. Well, so we've got a sub 1. We know that one. A sub 1 is 3. So we know the first one. So then what I need to find is a sub 2. And what we're going to do to find a sub 2 is use the formula that we've been given. And that right there is the formula. This here is basically just telling you not to go to like negative number of terms. Like we don't want to know a sub -1. All right, that's what we're talking about there. And so that's just saying make sure you keep the positive numbers. And here's normally how I do it. I try and go slow on the first couple until I can figure out the pattern. And once I figure out the pattern, then I go a lot quicker. So in other words, I need to find a sub 2, and so this basically right there has to say a sub 2. And the only way that can say a sub 2 is if n is what number? I think that's a plus. N plus 1. So if n is 1. If n equals 1, because it says n plus 1 right here. So if I made n 1, do you agree once I put it in here, it'll be a sub 2 is what it would say? Again, it'd be 1 plus 1. Right? Now I make a note of that because people do a lot of things wrong later in the problem. This n equaling 1 that I have written down, really, it doesn't necessarily solve anything for you. But now you write down the 2 because it's right here. And then it would be a sub, well, it depends on what n is at this particular time. And what is n right now on the problem I'm trying to solve? It's 1. That's why I wrote it down, so that we can make a note that it's a sub 1. And then it also says minus 1. Do you agree with that so far? Any questions how I substituted that information into this formula up here?
So you just take the term you're looking for. You just take the term that you have, like a sub 1, and you put that 1 in for n, is what you're saying? Always?
What you do to solve these is you look here, and I know I need a sub 2. What n value is going to make that happen?
1.
If n is 1, and then you use 1 that entire time for n until you have solved the one you're looking for. I think when you see the next term, it'll make sense. So this is a sub 2 equals 2. Well, what is a sub 1? It's 3. It's right up here. A sub 1 is 3. So you replace it with 3 and then minus 1. So a sub 2 is, very good, is 5. Now what you might think then, oh, a sub 3 has to be 7 then. Well, no, that's if it was arithmetic. Okay, and I told you this isn't necessarily going to work out this way. What these do is it uses terms we currently have to find other terms. There's been a formula set up for us like this one has here. So what's the next term I want to find? And I'll use a different color. A sub 3 is the next term I want to find, right? And so I need to make this right there say a sub 3. And there's only one n value that's going to make that happen. And if that's if n is 2. Now I make a note so that as I write through this, I don't put the wrong term down. So it makes this a sub 3 equals, and then there's a 2 in the formula, and then a sub whatever n is. And that's why I make a note so I don't forget what n is. N is 2. And then minus 1. So to find a sub 3, I take 2 times whatever a sub 2 is. A sub 2 happens to be 5. So a sub 3 is not 7 like we thought it might be earlier, but it's 9. So do you notice this is neither arithmetic nor geometric? Okay. But is there a definite pattern? Yeah, and there's a lot of ways you can find the pattern. It depends on how your brain works. So I'm going to kind of show you these 2 that I did here in red and blue are kind of if you follow the formula. But I look at it this way. What have I been doing this whole time? I've been taking 2 times the previous term and then subtracting 1, right? That's all I've been doing. So let's just keep doing that. So to find a sub 4, let's take 2 times the previous term, which happened to be 9. So take 2 times that, which is 18, and subtract 1, you get 17. Okay. Now, somebody in the other class said, well, doesn't it go up by 2, 4, you know, and they kind of looked at it that way. And there is no coincidence there because of the 2 that's in the equation. Okay. So have I found all of them I'm supposed to find? Okay. The question was, how did I find 17? Well, what I did is instead of writing the formula out, it's basically taking 2 times the previous term and subtracting 1. That's all it's doing. So to find a sub 4, I took 2 times the previous term and subtracted 1. Okay. Now, are you always going to find out that general formula? Well, maybe not. You might not be able to figure that out. But once you do use it, it's going to make things go a lot quicker. Okay. Would anybody like to see using the formula again? Or now that we figured out times 2 minus 1, are we good? We're good? So to find a sub 5, we take 17 times 2, which is 34, minus 1 is 33. Then you take 33 times 2, which is minus 1 is. So once again, you might look at, oh, it's going up by a certain amount, or you may find a pattern on your own. But once again, the point to be made here is neither arithmetic nor geometric. Very different. So if I was to ask you to add these up, there's no neat little formula I can give you that's going to add these up for you. You would have to find the terms and add them up. So if I said to find the sum of the first 6 terms, you would do this and then add them up. That's not what I asked for here, but that's really the only way to do it. Okay? So that's one way they can write these types of terms. Here's another way. This is probably the easiest of the ways they can write it. It says determine the first 3, they call it iterations, so x sub 1, x sub 2, and x sub 3 of the function. Now they actually gave you the function, it's 4x minus 2, and it's telling us x sub 0 is 2. According to what it said earlier in this question, does x sub 0 count as one of the terms? No, it doesn't. It says to find x1, x2, x3. Well, let's do that. It's quite simple. To find x sub 1, all you need to do is take x sub 0, which happens to be 2 in this case, and put it in the function. And tell me what you got. So if you put 2 into the function, you get 4 times 2 minus 2, which I've been told is 6, which is correct. So do I do the same thing to get x sub 2? Well, then I'm going to get 6 again if I do. What do you suppose you're going to do? Yeah, let's now take 6 and put it in to get the next one. You take 6, put it in, it's 4 times 6 is 24, minus 2 is 22. And x sub 3, all we have to do is take 22, put it in there, and that gets a little bit bigger, is 86. Yeah. So as you can see, this notation quite a bit simpler than the other one. The key when they ask for iterations like this is that x sub 0 doesn't count. Any questions so far? Okay, example 3 right now on your own, and I'll make it a little easier on you. Let's change this number to 3.